Hi, welcome to the pre-calculus lecture series. And in this video, we're going to start a chapter, new chapter. It's a chapter 2. We're going to talk about the functions. And so the section 2.1, basically we're going to give some basic definition of the functions. So for the whole chapter 2, we're going to, like a few major topics we're going to talk about will be the basically the first one, like we're going to talk about here, is the definition of the functions and what is the domain, the range, those things. Then we're going to talk about the detailed linear functions. Then after that, we're going to talk about the transformations of functions. Then after that, we're going to talk about how to combine the functions and how to find the inverse function. So that's basically are the 5 major topics we're going to cover in these chapters here. Okay, so let's start with section 2.1, the basic, what is the functions and how do we define the functions here. Okay, so now I'm going to go to the worksheets and we're going to start to take a look. Okay, so what is the definition of the functions here? Okay, so let me write it down. What is the definition of the functions here, right? So we know functions here. So a function, we typically use f. You can use any other letter, G, H is fine. So we say the function is a rule. Okay, let us assign. Okay, let us assign to each element. To each element x in a set A exactly one element and we call the f of x in a set B. Okay, so there are a few things we need to be careful, the key word here. So first ones here, we say the function is rules here, right? So it's kind of like depends, how do you define one rule? What do you want to define the rule of this function? So for each element in the A, then we're going to, here is the most important ones here, we're going to accept exactly one element, we call the f of x. In the set B here. So this is how we define the function. So for examples here, right? So in here, if this is your set A and this is your set B here, okay? So for example, set A, I have 4 numbers. I have 1, 2, 3, 4. Okay? Then in here, set B is here. Let's use a different color here. Set B, I have this number is 20, and this number is 30, and this number is 40 here. So we assign, that means we can define, right? So we can define the relations here. So whatever the relation you like, we can say, okay, so in here, from this point, I say, hey, from the 1, you go to 20. And for 2, you also go to 20s here. For 3, you go to 30. And the 4, you go to 40. So this is relations here from the A to B. So this is, we call this a functions, right? So the way you write it, right? So for example, here, this one's here, you say f of 1. So that's how do you write these relations, right? So the relation you write is like f of the 1, see here, let's try to here. So that means this one you said f of the 1 is equal to what? Is equal to 20s, right? So 1 is your numbers here. Then f of the 2 equal to 20. F of the 3 equal to 30. F of the 4 equal to 40. See here. This is, 1, so they can find exactly 1. So then this is a function. So you will say, hey, but 1 and 2, they find the same one. That's fine. So it's still, they have to, they can find the same one, but it's just like one element in A. You cannot find the 2 elements in B. So for example, let's take a look at these ones here, right? So if this is, let me get a little bigger here. Okay, so in here, so if you say here, this is A, this is B here, okay? So now in here, the A, I have 1, 2, 3, 4, just like we did before, 1, 2, 3, 4. And the B's here, I have 10. This point is 10. Let's get a different color, and also let's get the B a little bigger here. So we can have enough space. So the B is here. So for example, this point is 10, right? This point is 20. This point is 30. This point is 40. This point is 50 here, right? So now if you say, okay, so in here, my 1 go to 10, then my 2 and go to 20 and 30 here. Then my 3 go to 40, my 4 go to 50. So from here to here, right? So from here to here, this is, we say, is not a function here. Right, not a function because of A. So which one's not a function? This one violated the rules, right? Because this one, so 1, 2, 1, the 2, this number get into a 2, the y value or f of x value. So I know this is not a function. I typical like use the example I was said, like A is like a boy, B like is a girl here. So you invite them to the homecoming dance, right? So like if you invite them to homecoming dance, so if you have 4 boys and 3 girls here, so the both boys, 1 and 2, they can invite the same girl. But then here, like if you have boys, 1, 2, 3, 4, so for 1 boy, you cannot invite 2 girls because then to learn which girl you want to go dance with, right? So that's why be careful. The function has to be what? Has to be 1 to 1, not 1 to 1. One value at the A, you have to have 1 value at the B. That's it, all right? So the set, this set, the A, the where they found, we call it, this is the domain of the set. And then this one's here, the B, we call it is the range of the sets here, okay? So like, also like some people, some book, I like this kind of graphs here. It's kind of like it's machines here, right? So it is, you have some equipment here, like let's say here, they do like a graph like this. Okay, so that means is something here, you come in, right? So you get an X, right? So the X come in, this we call this input. And then your X go put it inside these machines. Then you have certain functions, that means a certain rule. Okay, then the output here, then this one come out is what? Come out is f of x, or some people say it's y, so this is what? This is my output here. All right, so that's basically the function. The one domain number can only have 1 range number, but like the 2 domains values, right? They can form the same range value, that's fine, but just like 1 value here, you cannot give, go to the 2 value. That's just not a function here. Okay, so the next is here in this section, they say how to evaluate the functions here, right? Okay, so here I have an example. Let me show you how to evaluate the function. So like let's say the f of x, right, is 3x squared plus x minus 5. So when they talk about I want to find the -2, what's that mean? That means every value in here, you need to replace, you need to replace the x value with what? -2. So this ones here will be easy. So let's try to do it. So this is -2. So be careful, right? So it's every x value we replace with negative 2. So this is 3. Then this is negative 2. Be careful that this is negative 2, the whole thing squares, right? Then plus negative 2 minus 5. So here they just basically try to test whether you know how to plug the number, right? So be careful, negative, negative, positive, right? So this is 12 minus 2 minus 5. So what is your answers here? So this is what is 5, right? Okay, now let's take a look at the second one. So f of 0, that's the same thing. That means every value of x you need to replace with 0. So this will be 3 times 0 squared plus 0 minus 5. So what is it here? Negative 5, right? Okay, so this is pretty straightforward. So f of 4, what is f of 4? That means every x value you need to replace about what? 4, right? It's plus 4 minus 5. And so what is the values here? You will be 4 times 4 is what? 16, right? So it's 48 plus 4 minus what? Minus 5. So what is the answer? It's 47, all right? So the D, this is the one a lot of students will make a mistake. Is like because every time we're dealing with fractions, then we have a little bit of, sometimes it's easier to make a mistake. So the same way, every x value you replace with 1/2 the square plus 1/2 minus 5. So here you will be 3/4 plus 1/2 minus 5. And you try to find the common denominator, you will find that this answer is negative 15 over 4, right? So this is a negative 3.75. So that's how do we evaluate the function. So you basically, substitute the value of the x with your values here. Okay, so now this is the problems here, problem number 2 here. This is a very important practice, special the part D here, because this is a pre-cal, right? So it's supposed to prepare you to do the calculus. So the reason why I said the D is very important, because when you go to the calculus in the first chapter, when we try to derive the derivative, so this will be the format we use. So we need to be very familiar with how to do this and how to simplify it, all right? So that's why when you go to calculus, we will say, hey, this is exactly how to our definition. I would say f prime A is equal to limit h approach to 0. Then this is h, this is fa plus h minus f of a. Of course, in here, I just write here, you say, what is f prime a? Don't worry about that. That's what I just want to tell you when you go to the calculus. See here, right? These terms here, that's what is part of these here. That's why I put it here to let us practice. We need to be good at it so we can be ready when we go to the calculus. Okay, so now let's take a look at f of a. So what's that mean? That means every x you need to replace with what? Replace with a, right? So this will be 2a squared plus 3a minus 1. All right? Okay, and then the b here, the b here is f of negative a. What's that means here? That means x replaced with negative a. So it's negative a squared plus 3 negative a minus 1. Be careful about the negative signs, right? So negative a, negative is what? Positive. It's 2a squared minus 3a minus 1. Okay, now the next one is here. This is f of a plus h. Okay, so this one is here. Is be careful. What's that mean? That means every x you need to replace with what? A plus h, right? So, okay, so be careful here. So let's see here. So 2a plus h to the square plus 3a plus h minus 1, right? So you replace with each x here with a plus h. Okay, now let's try to FOIL it. So this is a plus h squared. I FOIL it. I will become a squared plus 2AH plus H square, then plus, what is the property I'm using here? Distributive properties, right? So plus 3A plus 3H minus 1. Okay, so now I'm using the distributive property again, right? So the here you distributive property again. Okay, so it will be what? It will be 2A squared plus 4AH plus 2H squared plus 3A plus 3H minus 1. Wow, looks pretty complicated, right? But that's fine. Okay, this is part C. Okay, now let's take a look at part D. So how do we do that? So part D is here will be f of A plus H minus f of A over H is here. We already have the f of A plus H. So this is 2A squared plus 4AH plus 2H squared plus 3A plus 3H minus 1. Then minus f of A, right? F of A is, where is f of A? Here is f of A, right? So minus f of A. So it's a minus here. Be careful, minus. So put them into parentheses, 2A squared plus 3A minus 1. And then divided by H here. Okay, so now in here, okay, now let's simplify it a little bit. So remember, when you do math, the things you just need to be very careful and very patient, right? So 2A squared plus 4AH plus 2H squared plus 3A plus 3H minus 1. Then minus 2A squared minus 3A plus 1. That's right, because this is where the people sometimes make a mistake, right? So that means when you try to find the distributive property, you need to, this negative sign has to go over for every one of them. Okay, now let's take a look at what we can cancel. Oh, this one is a negative 2A squared, positive 2A squared. Pretty good. Negative 3A, positive 3A. Plus 1, negative 1, excellent. All right, so we cancel that. So we simplified. Okay, so here this is H, then this is 4AH plus 2H squared plus 3H. Right? Did I miss anything? No. All right, that's good. I guess I got all the terms here, right? Okay, now in here, let's see here. Now in here, okay, I can what? I see H, I can factor the H out. So this will give me 4A. What is the next terms here? Will give you 2H. What is the last terms here? Will give you 3. Okay, so beautiful. H cancels. So your answer is 4A plus 2H plus 3. Okay, and that's it. It's pretty cool, right? Okay, so now the next things here, we're going to talk about the domain of the functions here. The domain of the functions in general is pretty, unless they give us a specific, the area. So typical, the domain of the functions, right? So let's always say the typical, the domain of the function we will start as the from the negative infinity to positive infinity. That means the whole number, except few situations, right? So except a few situations here. So the things here we need to careful here. Right now, from our just starting level, we're going to be careful is like if a function have a fraction. Okay, so if a function have a fraction, what's that mean? That means the denominator cannot be 0. So that's why you need to what? You need to exclude the function, make the denominator equal to 0, right? Okay, so then the next things here from our levels here is the roots functions, right? So for the roots functions, so these roots we talk about the even roots. Okay, so the even roots, that means the square roots, the fourth roots, the sixth roots. So for the roots functions here, so we need to be careful here is the value inside the roots. What happened here has to be what? Has to be greater than 0. Right? So greater than or you maybe let's do this way because we're doing the except, right? So the let's say here, so the value inside the roots, right? Okay, so we say the value inside the roots is what? Cannot, right, be what? Negative. Right, so for example, if you put it into your calculator, you say -2, what they will give you there? So this is arrows, right? So anything with even roots, so like square roots and six roots and eighth roots, so this is the even roots, right? So like if you have a cube roots, the other roots does not matter here. So later, after we talk about more functions, like we talk about the log function, we might add a little some more restriction to the domain. But so far, for right now, for all the functions we're dealing with, those are the two things we need to be careful, right? So in general, it will be all the real numbers, right? So we start out the domain with what? With all real numbers, right? So from negative infinity to the positive infinity, then we want to exclude out what could be the trouble, right? So let's take a look here. Okay, so the first ones here, we say, hey, they want to find the domain of the functions here. Okay, so like we say, okay, this is the domain of the function. Immediately you say, hey, this one has a denominator. Okay, so let's, so I know the denominator cannot be equal to 0, right? So now I need to take a look. What will be the value will give the denominator equal to 0? Right, so this will be x squared minus x equal to 0. So I can factor the x out. So this is x minus 1 equal to 0. So what is the value of x? So x equal to what? X equal to 0 or x equal to what? X equal to 1, right? Because if you multiply two values equal to 0, that means this value equal to 0, this value equal to 0, right? That's why I give you x equal to 0 and x equal to 1. So I know this function, the domains here can be, the domain we always say start with the negative infinity to positive infinity, but except 0, that means here, this is 0, I cannot be. And this point here is 1, I cannot be here, right? So it's a whole real line, but with this two empty set. Okay, so how do I write it into the domain format? We'll say it's negative infinity to 0, right? So it's an open parenthesis because it cannot be 0. And the union, then 0 to 1, right? Then union what? 1 to what? Infinities, right? That is my domains. Okay, so you start with real number, then you see, hey, what are the number I need to exclude, right? Okay, so now let's take a look at the second one, the gx here. So this is 9 minus x squared. So you say, oh, this one here is 9 minus x squared. And this is what? This is square roots, right? So that means inside this one's here is what? Cannot be less than 0, right? So now let's see what is the less than 0. So if this is less than 0, right? Okay, so now in here you will move the x squared. So it's 9 is less than x squared. Then you square roots both sides. So it's x squared greater than 9. So that means x is greater than 3 or x is less than -3, right? So it's kind of like the intuitively makes sense. If you put x equal to 4, so it's 4 is greater than 9, right? Okay, so now let's take a look here. This is your real numbers here, right? So it start with, okay, so start with a real number, but then we say we need to exclude the, so x cannot be greater than 3. So this one cannot be greater than 3. And the x cannot be what? Cannot. That's why this is except, right? So what is my x here? The x is where? It's inside here, right? And so what is, how do I write it? Okay, so let's write, so the domains here is what? Domains here, it will be -3 to +3, right? So be careful, I use the bracket. Why? Because the 3 can be in the domains here, okay? So that's what the, you can exclude. So if you want another way to solve it, right? You don't need to exclude. Another way, you can just say here, you can say 9 minus x squared has to be greater than or equal to 0. So the 9 is greater than or equal to x squared. That's why the x is from -3 to 3. So you can solve this one. So if you solve this one, you use the, we call it except, right? Except this, that means you need to exclude, right? Okay, so now let's take a look at part C here. The part C, they have h of the t is equal to t and the t plus 1 here. Okay, so I have something in the denominator. So I have this whole thing in the denominator. Also, this whole thing is a root, right? So I know the denominator cannot be equal to 0. And the root, the inside roots has to be, cannot be negative. So combine these two conditions, so I will see the t plus 1 has to be what? Has to be greater than 0. See here, I cannot include this equal sign here. This one is not going to work. Why? Because if equal to 0, your denominator will be equal to 0. So it's not going to work. So then you solve this one, so you'll find out, oh, okay, so t has to be greater than what? Greater than -1 here, right? So this is the one you solve it. And then in here, if you take a look, this is your lines here. So this is 0, this is -1. So it's tell you xt is greater than -1. So what is my solutions here? So it's a circle greater than -1, right? So that will be my solutions for the domains here. So this one you can write a domain. How do you write it? So you can say the domain is from -1 to infinities, right? So be careful about here, right? Why I cannot include the equal, and why in here I can include the equal. It's because this one is not on the denominator. The reason why I cannot include the zeros here, because this one is on the denominator, so I cannot let the denominator equal to 0. Okay, so that is the section 2.1. It's a very simple sections here. So remember the key concept. What do we cover here? The key concept is function has to be what? For every values, right? So this is the first very keys here. We'll say for every value, you can have exactly 1 f of x, all right? Then the next things here we say, find the evaluation. Which one is very important? This one is very important, right? Because like I said, this is the basic definition we're going to use when we go to the calculus, right? And the third important concept is about the domains here. So like right now for our level, we need to remember we always start the domain with the whole real number lines, right? And we said if they have a fraction, then the denominator cannot be zero. So we need to exclude zero. If a root function, and be careful, it's even roots, the other roots does not matter. Okay, so the value inside the roots cannot be negative, right? So that's it, all right? So I hope you highlight those 3 points and be very careful about these 3. Okay, that's it. And have a nice day. And don't forget, you can go to work on your homework assignment, so get more practice, and so you'll be able to get master those concepts and get familiar with it. All right, that's it. It's nice to talk to you, and hope to talk to you. Looking forward to talk to you in our next lesson, lesson 2.2. Okay, bye. Have a good day.